I'm Anil Kumar, and in this video, we'll try to understand how to graph a reciprocal trigonometric function. The question here is, sketch the graph of y equals to minus 2 secant 2x plus pi minus 1. Now, let us factor the inside term and rewrite this equation. We can write this as y equals to minus 2 secant of 2 common, right? And we get x plus pi by 2 bracket close minus 1, correct? Now the strategy here is, as a guideline, we could first sketch the cosine function and then we will sketch the secant function. So that will form the guidelines for us. Now when we say that the axis is minus 1, so minus 1, let's say this is a graph and that is minus 1 for us. Let me sketch the axis first. So this is the axis for us, which is at minus 1, right? So that is the axis, so which is y equals to minus 1. So this particular value, correct? Now when we say that the amplitude for us is 2, right, we'll consider minus as a reflection, but let's say here amplitude is 2. That means the maximum is 2 units above. So I'm just sketching a dotted line indicating that my cosine function will have maximum here and the secant function may have a minimum, right? Now, so 2 units down. So these are my guidelines which really help us to sketch the graph, correct? So this is because of the parameter 2, which is vertical stretch, right, by a factor of 2. So we have taken care of horizontal translation and this. Now let's look into the time period, right? Now as far as the time period is concerned, what we have here is k values given to us. So we say k is equals to 2. So that means time period t should be equals to 2 pi divided by 2, which is pi, right? So that is the time period. And secondly, what we also get from here is the phase shift. So phase shift, let me write p as the phase shift. It is plus pi by 2. So I'll write minus pi by 2 units. So that means it is left. Is it okay? By pi by 2. So that is the phase shift. So to incorporate this, let us use a proper scale. So we have unit 1, 2, 3, 4. Since we are working with pi by 2, always we need quarters is a good thing. So 4 could be a good way to go about, right? Or we could take 8 also, since, okay, 4. So we could say 4 is pi for us. Okay. So 1, 2, 3, 4 is pi for us. So we have 1, 2, 3, 4. This is minus pi for us. So what I will do is actually sketch only one wave for it. Okay. Let me go ahead here. So 1, 2, 3, 4. So that becomes 2 pi, right? So let's say we have this much. Okay. Now cosine function starts, now this is negative. Negative tells us that the function really starts with minimum, correct? This is negative. Function starts with minimum. And the cos function, if I am first drawing, in that case it is starting with minimum, and the minimum has been shifted pi by 2 units to the left. So this is my minus pi, so this is pi by 2 units to the left, and that becomes my minimum point, correct? Now one wave is of pi, which is 4 units for us. So the next minimum will be after 4 units. So 1, 2, 3, 4, right there. Do you get the point? Maximum is going to be halfway between these minimums. So that is the point, correct? Likewise, I can get other points also. So get 1, 2, 3, 4. Since we know that the period is 4, we can go 4 units left and right and kind of get our guidelines. You get the idea, right? And of course, when it crosses, it will cross on the axis. Is that okay? So it will always cross on the axis. And so those are the other points to consider. So if I am actually graphing my cosine function first, right? So my cosine function will kind of look like this. It's kind of easy to draw that first, right? So that is the whole idea, just to give you steps of how it should be done. Okay, so what I've done here is just drawn a cosine function 1, 2, 3, 4, which should end at 2 pi. So, okay, so we'll go like this. Correct. So that is the kind of wave which I have just sketched for you. Now, since we are actually graphing secant, these points which before translation were on the x-axis. So at these points we have the vertical asymptotes, right? So for secant, we'll have vertical asymptotes on zeros of cos before translating down, right? So we will just sketch these zeros as vertical asymptotes on secant function, right? So these points could be here before horizontal translation. So they will become zeros for your secant function, right? So these zeros, as you can see, are spaced pi by 2 units, correct, away. So these are the zeros for secant function. Correct. Now we have all the guidelines to sketch the secant function, right? So now we can sketch the secant function. For example, if you start from here, well, the axis is here, why not start from here? So it will go upwards from here, correct? Now, instead of 1 unit, because it is 2, so in the first case, it should cross here at 2, right? So we'll have a function which is kind of like this. Do you see that? So that becomes the secant graph for you. So that is how you can actually sketch the secant graph. So that is an easy way of sketching secant graph. To get the exact values, what you could do is you can make a table of values. So I'm not doing that part, but in your graph paper, you can space it out a little bit more. Find the values for pi. So find the values for, I should say, you can start from 0, and then you can see it is symmetric. So you can find the values for 0, pi by 4, pi by 2, pi, correct? So likewise, once you get these points, those can be plotted and you get more accurate value. But broadly speaking, that is how your secant graph is going to look for this particular function. I hope that helps. Thank you and all the best.